Hi, warm welcome, everybody. Thank you for being here. Get yourself ready. Grab a notebook, a pencil, or a pen to write with. Whatever you choose is fine. This is math from the void. Math coming at you out of nowhere. And today we have another non-calculator problem from the 2025, that's this year's AP Calculus AB exam. How were the free response questions? Were they tough? Did you have enough time? It's about 15 minutes per question. This one was graph focused, using some nice geometric shapes. I see some semicircles. Looks like the same size semicircles. Anyway, if you want to give yourself about 12 minutes or so to try to solve this, go ahead and do that. And then you can come back and see how I did it here. Without further ado, let's get started here. So the continuous function f is defined on this interval from -6 to 12. The graph of f, consisting of two semicircles and one line segment, is shown in the figure. Now we're going to define a function from this graph. G is going to be the function defined by the integral from 6 to x. And we need to be aware that things are starting off from here. So any area that I'm doing going this way, that's positive. But as I go backwards, this is negative, and this is actually positive. And that's because the limits of integration would be in the reverse order. We'll probably see that come up somehow. All right, let's start with g prime of 8. G prime of 8 is going to require us to use the second fundamental theorem of calculus. So here we have g prime is simply going to be the derivative of f, wow, they look kind of sloppy, of f of x minus capital F of 6. Well, that's simply going to be f of x, because the derivative of a constant is 0. All right, so g prime of 8 is just going to be simply f of 8. And we can use the graph to tell us that. It's going to be 1. Very easy to knock out part A. Okay, part B. Find all values of x in the open interval from -6 to 12. So all values at which the graph of g has a point of inflection. So what does that mean, to have a point of inflection? That means that g double prime changes sign. It either goes from positive to negative or negative to positive. Well, we don't really have g double prime. Right, we have g prime, which is essentially just f of x, which means g double prime is essentially just f prime of x. So we want to see when this changes sign. That's just the slope of the graph. So when does the slope change sign? Right here. It goes negative to positive, and also here it goes positive to negative. And then at 6 it also goes negative to positive, so it changes sign here. So it changes sign a few times. We don't have to find the point of inflection, we just have to find the values of x. So that's going to be at x equals -3, at x equals +3, and at x equals 6. Oh, yeah, interesting. So we have 3 values there. Okay, let's take a look at part C. It says find g of 12 and g of 0. Notice that one of them is in front of the 6 and one of them is behind the 6, so we just have to be a little bit careful about that. G of 12, fairly straightforward. It's just the integral from 6 to 12. F of t dt. And this is literally just the area of like a triangle. Look, base is 6, height is 3. Super easy. So we just get 9. Not bad at all. Now for g of 0, we do have to be a little bit careful. But you'll find something quite interesting of g of 0. So g of 0 is the integral from 6 to 0. Of course, we don't want to do an integral with the limits of integration like that. We want to flip it. So negative integral from 0 to 6. So the integral from 0 to 6, if we take a look here, it's just a semicircle. I didn't even have to erase all that, but it's just this semicircle here. So what is that area underneath that curve? It's just a semicircle. So the radius is 3. Therefore, the area of that circle is pi times 3 squared, but it's only half of a circle. So it's a negative 9 pi over 2. That's the value. Okay, pretty easy. Straightforward stuff, you guys. Now let's wrap it up with part D. Find the value of x at which g attains an absolute minimum on the closed interval from negative 6 to 12. Okay, so we have to consider some candidates here. We have to consider g of negative 6, of course. We have to consider g of 12, which we already have. G of 12 was just 9. And then we're going to take a look at g of negative 6, which is going to be the integral from 6 to negative 6, which is quite simple, is it not? Look at this. It's just going to be negative integral from negative 6 to positive 6. But if you take a look at the integral from negative 6 to positive 6, we just have these two identical but opposite regions. These are just going to cancel each other out. So from negative 6 to 6 is just 0. So the value of our endpoint there is 0, and the value of our endpoint here is 9. We're not done, though. We don't just have to check endpoints. We also have to consider critical points. Where are our critical points? Well, our critical points are when the derivative is 0 or undefined. And the derivative g prime is just f of x. So when is this equal 0 or undefined? Let's take a look at the graph. I see that it's 0 at negative 6. We already got that one. It's 0 at 0. It's 0 at 6. So those are the only points we'll consider, 0 and 6. We've already looked at the endpoint, negative 6. So when x equals 0, when x equals 6. Well, obviously, when x equals 6, we're not going to get anything impressive. G of 6 is just the integral from 6 to 6. That's 0. Okay, so it's the same thing, actually, as g of negative 6. But now let's look at the other critical point, which we already saw. That's x equals 0. What was g of 0? G of 0, we have it from a previous portion. It's negative 9 pi over 2. And that is actually the smallest value out of all of these candidates. This is positive. These two are 0. That's the minimum value. And what is it asking for? It's asking for the value of x. It does not ask for the minimum value. It just asks for the value of x. So we will say x equals 0 produces a minimum value. Whoa. produces a minimum value for the function g. Okay, and without further ado, that's a wrap. So I have to say that was probably the easiest question on this free response portion, including the calculator and non-calculator section. Very straightforward stuff. They give you a graph. They kind of do a little trick where they put this, lower limit at a 6, so it's not all the way back. You have to look at the limits of integration, flip them a couple times, but it's nothing unmanageable. Very, very doable. Make sure you're using the Fundamental Theorem of Calculus properly. When you take a derivative of an integral, they basically cancel out, but I want you guys to do things safely. And if anyone's learning from this for next year, definitely take note on that. These small details really help your solving process, makes it effortless. Know what your definitions are of a point of inflection, know how to look for absolute minimums and maximums on an interval, and that'll be enough blab out of me. I'll catch you guys next time in the void.